Good morning, students. So today, we'll start with electronegativity. Okay. Like last time we did electron affinity. So we'll see what is electronegativity today, right? Okay. So last time finished affinity. Now suppose I take a bond AB. Okay. Now students, in this bond AB, yeah, it's a covalent bond. Now what is a covalent bond? You will have sharing, right? See, we are doing last time we are doing periodic properties, right? So we are seeing a new property now. Electronic. So now it's a covalent bond. They're sharing, right? Now, if B is more electronegative, fine. One minute. Okay. Students, let's see this now. If B is more electronegative, okay, this shared pair of electrons, remember you'll have one pair of electrons, right? Shared by both A and B, right? If B is electronegative, the shared pair of electrons will be taken more by B. Okay. So the electrons will spend more time with B actually compared to A. So we say B is more electronegative compared to A. Okay. So let me repeat. If B is more electronegative, right? That means this shared pair of electrons, right? Yes. Will spend more time with B compared to A. Okay. As a result, what will happen? This A will get a slight plus sign and this B will get a slight minus sign. Why B gets a slight minus sign? Because electrons are spending more time with B. We say B is more electronegative. Okay. Yes. So what is electronegativity is defined as the tendency to pull the electrons towards itself. So B is trying to pull the electrons towards itself, right? So we say B is more electronegative. The tendency to pull the electrons towards itself in a covalent bond. Okay, in a covalent bond. Fine. See, the electrons are spending more time with B. That doesn't mean that the electrons have gone completely to B. Very clear? If that is the case, then it is shown that it's called ionic bond actually. Like suppose electrons are spending, listen here, all the time with B, then it will become ionic. Fine. That is the extreme case. Clear? Here it just so happens that the electrons will spend more time with B actually, right? Fine. This is what is called electronegativity. Now let's take an example now. So because of this electronegativity, A will get plus and B will get minus because electrons are spending. Let's take an example now. Let us take HF. Now here we say that F is more electronegative. What does it mean? It means that the shared pair of electrons, whatever two electrons which are shared actually, right? Okay. Yes. Are spending more time with F. Fine. They are spending more time with F compared to hydrogen. So as a result, H will get a plus sign and F will get a minus sign. So you'll get plus minus, right? Fine, students. So there is a charge developed in the molecule. You see there is some charge and such type of molecules, students, they are called polar molecule. So what is a polar molecule? Polar molecule means electrons are spending more time with one of the atom, right? Minus sign will come, plus sign will come. Students getting it? And what is the extreme case of electronegativity? The electrons completely go to F. In that case, it will become like this ionic bond actually, right? Okay. So I hope you're getting this right. So F is supposed to be electronegative. Let me give you some more examples now. For example, HCl. This is also polar bond, right? So electrons will spend more time with B, right? So chlorine will get a minus sign, hydrogen will get a plus sign. Fine. Hydrogen has less tendency to pull the electrons. Okay. Now electronegativity will decide whether the bond is polar or not. Okay. Suppose I've got the same atom. Suppose I've got H and H. Now here you will get equal sharing, am I right? So in this case, this bond is non-polar. So there will be no polarity in this, right? Fine, students? Okay. Now, if the difference in electronegativity, students, the difference in electronegativity is very high, okay? Like let me give you an example now. For example, sodium and chlorine is very, very high, okay? In that case, it will form an ionic bond. In that case, what will happen? Sodium will completely give the electron and chlorine will accept it. So when will you get an ionic bond? Clear? When the difference is very high, electron. Actually, the difference in electronegativity, if it is students greater than, scientists have calculated this, if it is greater than 2.5, then you will end up with an ionic bond. It's very, very high, like clear. Then you will get complete transfer. Okay, fine. Getting it? Now, how do you calculate this electronegativity? Okay. Electronegativity is calculated by various methods. Remember one very important thing. It is calculated. Okay. It is not experimentally measured. Remember, it's just calculated. It is calculated by using the bond energies. For example, like we get a bond like this. We get a bond AB. Okay. Now, students, if you know the dissociation, by the way, I'll just tell you what is dissociation. Suppose there's a bond AB, right? If you want to break this bond, you require some energy. That energy is called bond energy. So there's a bond AB, right? I want to break it. Some energy. What is that called? Bond energy. Okay. Now, students, you can calculate electronegativity by knowing the bond energies. Okay. If you know the bond energies of AA, if you know the bond energies of BB, and if you know the bond energy of AB, you can calculate electronegativity. Okay. There is a formula for that, but don't worry, students, that formula and all is not there for your syllabus. So don't break your head. Just remember that you can calculate if you know all the bond energies, right? Okay. So you can do a simple calculation, right? There are various people, various scientists, who have done calculation, right? Pauling. So there is something called Pauling scale of electronegativity, right? There is something called Alfred Rocho scale of electronegativity. Okay. So many scientists have done the calculation, Mulliken scale of electronegativity. So for you, you don't have to do all this calculation, all that. Just remember that you can calculate electronegativity if you know all the bond energies, right? Okay, fine. Clear? The third thing is fluorine is the most electronegative element in the whole periodic table. The most electronegative. Please remember this, very, very important. Okay. Most electronegative in the entire periodic table. Okay, fine. Now, one minute, students. Now, can you guess who will be the most electropositive? Yes, very good. Cesium is the most electropositive element in the entire periodic table. Okay. So fluorine is the most electronegative, cesium is the most electropositive, right? So what an ideal combination you have. The most positive is cesium and the most negative is fluorine. So obviously this bond will be, students, what? An ionic bond, right? Extreme case of the periodic table. One is highly positive, one is highly negative. You end up with an ionic bond. Okay? Very important. Now, how does it change? As you come down the group, Like suppose you take fluorine, right? Chlorine, bromine, iodine. As you come down the group, the electronegativity will decrease. Okay? Yes. As you keep going down, So who is the most electronegative here? Fluorine. Very good. Okay? And iodine is not that much. Now, what will happen as you go across a period? So down the group it decreases, right? Across the period it will increase. Fine. Let me give you examples now. Beryllium, boron, carbon, nitrogen, oxygen. So it will keep increasing. So who is the most electronegative? Fluorine. Fine. So it's getting it. So as you go across the group, down the group, sorry, decreases, but across the period it will increase. Okay. Yes. And students, one good news is that there are no exceptions. Like in other properties, we used to study exceptions, right? But here, one good thing is that there are no exceptions. It's very simple. Okay. In fact, you can remember the values also. So I hope you are getting this right. So I'll give you the values. Fluorine is 4. Fluorine has an electronegativity of 4 based on the Pauling scale, based on the calculations done by Pauling. A great scientist, right? Pauling. Fluorine 4. It's easy to remember. Before fluorine, what comes? Oxygen, right? 3.5. See, I'm not asking you to remember this. Okay, no need of. So, nitrogen. Okay. Now, these are the three most electronegative elements, remember, in the periodic table: nitrogen, oxygen, and fluorine. The three most electronegative elements. Clear? So, before nitrogen, 2.5. Can you guess who is that? Carbon. Carbon, nitrogen, oxygen, fluorine. Right? Boron. Yes. Boron 5, carbon 6, right? Nitrogen 7. So this is the order. So you see, you can remember also, it's not different. It's just a difference of just 0.5 students, right? 2, 2.5, 3. So fluorine is the most. Okay, fine. So that's all about electronegativity. So let me revise now. What is electronegativity? The tendency to pull the electrons towards itself. Suppose there's a bond AB, right? B will pull the electrons more towards itself compared to A. Okay. So B is said to be more electronegative. So, because of electronegativity, you get a charge, a small charge you get. And such bonds are called what? Polar. Okay. And more the difference in electronegativity, if you get a lot of difference, right, the bond will become more and more polar. Fine? It will become highly polar, right? And if the difference is greater than 2.4, students, if you are getting a difference greater than 2.4 between A and B, clear? The bond will become ionic. Ionic means what? A will become plus, B will become. Totally, A will lose the electron. See here. A will give the electron to B. It's highly electronegative, B. Clear? Okay, and then you just remember these values, down the group it will decrease, right? And across the period it will increase. And obviously, like fluorine is the most electronegative. Okay, so it's fine. So this is all about electronegativity, very important, right? Okay, just note down this, right? Okay, students. So that's all is there in this chapter. Okay, so we have done all the things in this chapter, right? There is one more thing, There's a committee, I think you have done in 10th standard, like this committee is called International Union of, Pure and Applied Chemistry. Okay. Now for elements greater than 100, suppose, the element, atomic number, right, is greater than 100, okay, then there's a way of naming it. This committee has told us how to name that compound, just, it is greater than 100. Less than 100 is okay. Now for that, we have a nomenclature. Okay. Okay, students? Yes. We have a nomenclature for that, just, very important. If suppose you are, suppose I want to name an element with 100. Fine. 100. Hmm? For 0, they use nil. So what is the word I'll use for 0? Nil. For 1, I'll use un. Okay. For 2, I'll use bi. For 3, I'll use tri. Okay. For 4, you can use tetra or quad. Okay. Now let us take first 100, then we'll go further. Let's take 100. So for 100, you have to use one un. So first you have to write un, right? Then for 0, I have to use the word nil. Again 0 is coming, right? Nil. Okay. For 1 un, 0 nil, another 0 nil, right? And the last thing is it will end with em. Please remember you have to end the name with em. Okay. So what you can call this compound as unnil nil. Yes, unnil nilium. Unnil nilium, right? That's how you name this compound. Suppose I want to name a compound like this: 1, 0, 2. Then I'll call this compound as 1, 0, nil. And for 2, I'll use bi. So what is the name of this compound? Unnil bayam. Unnil bayam. So in Tamil, it looks good, right? Okay, unnil bayam, right? That's how you name it. Very simple. Okay, this you have to use it above 100. So 1 means 1, 0 means nil. Nil is nothing, nothing is there means nil, right? By normally, we use it for 2. 1 is for 1, right? So unnil bayam. Okay, like suppose I want to name an element 111. How will you call this as? Unyam. But the ending should be em. Okay, students. So this is how you will do it, right? Fine. If the element is having atomic number greater than 100, fine. And one more thing, students, so that you can do it, right? You must remember is metallic oxides. Please remember one thing: metallic oxides. This you have done in your 10th standard. Are basic. See, there are many types of oxides. Non-metallic oxides are. Tell me. Same thing. Non-metallic oxides, acidic, right? So generally, metallic oxides are basic. Basic means when you put in water, you will get NaOH. Correct? Basic. Non-metallic will be acidic, right? There are some oxide students which are amphoteric also. Amphoteric means what? They behave as both acidic and basic. Like best example is, the very famous example is Al2O3, ZNO. All these are amphoteric, right? Aluminium oxide, you all know it's amphoteric, right? You will get acid also, you will get base also. Both behavior will be shown. Okay? And there are some oxides which are neutral. Neutral means, they will neither be acidic nor basic. Like for the best example is carbon monoxide. Okay? So please remember this also. Metallic, basic, non-metallic, acidic, you get some places, amphoteric, right? And some neutral oxides also. Amphoteric means both behavior will be there. Okay? Some of them are neutral also. Fine, student. Now, I think we'll start with a new chapter now, right? Because that's all is there in that periodic table. So, to students, today we'll start with a new chapter, chemical bonding, right? Okay. So, in periodic table, I'm again repeating you. You will get questions on ionization energy, electron affinity. That's very important. Okay. One more thing I forgot before we come to chemical bonding. Electron affinity is measured experimentally. Remember. Okay, the energy release, right? When you accept an electron. But electronegativity, what we did last, was calculated. That's the difference between electron affinity and electronegativity, right? This is experimentally calculated. This is just you do some calculation, right? I told you now Pauling did some calculations, right? So it's calculated. So this is more correct actually, right? Okay, fine. So I think if you know this much, we can start with our new chapter. It's chemical bond, right? Okay. Yes, in your NCRT class, I think you have a slight idea. Like you have almost done all the the entire chapter. I think, right? Some part of the chapter will be remaining. Okay, so this is a very important topic, very important topic for for NEET and IIT JEE, right? Now, what is a bond? Let's start with this chapter now. What's a bond? I'm talking of chemical bond. Listen here. Okay, so suppose I've got an atom A, atom B, right? And I think we'll do it a little bit faster, students, because you've already done this in NCRT, right? So I think what I'll do is we'll do question answer form. Like we'll try to do questions in this. That's I feel that's more appropriate. Am I right? Because we've already covered the basics in the NCRT class. Okay. So I will do one thing. I will start with some questions. Now, let me take the first question now. Suppose somebody asks you, NO, okay, is it paramagnetic or diamagnetic? That's the first question we'll start with this. Paramagnetic means it be attracted by a magnet. Okay? Attract a magnet, right? For example, iron. It'll attract iron. Okay? Now the condition for paramagnetic is in chemistry it should have unpaired electrons. What it should have? So what you have to do, students? Unpaired electrons, right? Just to test whether this NO has unpaired electrons or not. Okay? Just test whether the NO is having unpaired. One easy way of testing, I'll tell you, then we'll draw the dot structure and find out. I think we have done the dot structures, right? Clear? One easy way of finding out is just check how many electrons nitrogen has and oxygen. Okay? Fine. Let us check the valence electrons. Nitrogen has how many valence electrons? Or students, you can even take the total electrons also, nothing wrong. We'll take the total. Okay? This total is easy. Nitrogen has got 7. Am I right? Oxygen has got 8. Total electrons means atomic number. It's more easier, right? Atomic number. So how much you add up the two? 8 plus 7 will come out to be how much? 15. Okay? So I'll just rub this 1 minute. 15, right? Now 15, students, is an odd number. So whenever you have got an odd number of electrons, odd number, please remember, it will have unpaired electron. Okay? In this 15, 14 will be paired. Okay? So you will have one odd electron. Is that clear? One unpaired electron it will have. Okay? So student, that is how you decide. But this is easy way of deciding. We'll draw the dot diagram and also decide. Okay? So total electrons is how much? 15. Just add up. Out of that 14 will get paired up. One will be unpaired. Okay. So we also call, listen here, we also call this as odd electron molecule. Okay. So if it is an odd electron molecule, it will be paramagnetic. Please remember. Very important. Okay. Now this is one way of finding it out. The other way is you draw that dot diagram. Remember students, you remember all these dot diagrams, we have done this in CRT, like what is the criteria? You should have octet, that's all. Okay. So we can draw it like this. Okay. Am I right? This will be the dot diagram for that. Nitrogen has how many valence electrons? 5. Oxygen has got 6. So we are showing all the 5 valence electrons. Oxygen also we are showing 6, right? Okay. And you can see very clearly there is an odd electron here. Can you see? I have shown with the red color. So you see there's an odd electron there, right? Fine. There is one unpaired electron. Clear? So student, you can do by this also, you can do by this also. Okay. Next question they will ask you is, will it lose that electron? Will it lose that? Yes, it will lose because from odd it will become, even. It will become paired up. So I will just, so NO, if it loses one electron, student, it will get the number 14. Already originally it had 15, right? So I hope you are able to see this color. It will lose that electron because it will become more stable. Okay, see, one very, very important thing in chemistry, if you are having unpaired electrons, please concentrate, unpaired electrons, that molecule is unstable. Okay, unpaired electrons will make it unstable. Because that unpaired electron wants to get paired up. Fine? So what it will do, how it will become, from unpaired to paired? By losing that electron. So NO will lose one electron, right? One more thing they can ask you in the exam, student, is NO dot. Suppose I've got two NO molecules, right? What they will do is they will form a bond now. By forming a bond, student, that unpaired will become paired now. Am I right? One electron here, one electron here. So they will form a bond. So it will form a dimer actually. Clear? Yes. So can you please note down these things? Please note it down. Okay, students. So NO, there are three properties of NO. Listen here. One is it will have an unpaired electron. Fine. That will make it magnetic. Second thing, it will form a dimer. That unpaired electron will become paired now, right? Form a dimer. And third thing is it lose one electron. It's more stable. Unpaired electron makes a molecule unstable. Fine. So by losing that electron, it will become stable. Fine. Okay, students, then fine. So I think we'll do this next time. Okay, we'll do more questions, like this next time. Theory part, though, I think you know. You know the theory part, right? Okay, then bye then, students. We'll meet you next time, right? Bye.